Good morning, student. Let's start today's class. Okay. In today's class, we are going to discuss about the second type of transistor biasing method, which is biasing with feedback resistor. Okay. Now, in this method, you see what is the difference is that in this method, this RB, okay, which is connected to the VCC or positive end, positive end of the VCC in the previous method, which is fixed biasing method. Okay, but here it connected to the collector. Okay, and this and as a base connected, other end is connected to the base. Okay, now you see this is the difference of this method. Okay, so since it connected to the collector, okay, so the IB, this IB is flowing due to the this collector, from the collector. Okay, so this IB or non-zero value of required zero signal base current is determined not by the VCC but by the collector current. Okay, but by the collector uh, CB, the collector base voltage. Okay, this VCB. Okay, so in previous method, okay, this IB is decided by the VCC. Okay, but here this IB is decided by the VCB. Okay, this V collector base junction voltage. Okay, now and the required amount of RB for that, the IB is 0 or 0 uh, signal collector current is flowing in the circuit is determined according to the circuit analysis. You see, okay, now in the circuit analysis, you see the RB, the required value of RB need to give the zero signal current IC can be determined in the following. Okay, the first one is apply KVL. Okay, apply KVL in the circuit. Okay, the which circuit, which closed loop, this closed loop. Okay, this sorry this closed loop. Okay, apply this closed loop, okay, in the circuit. Okay, so you see the KVL is VCC, this VCC, then ICRC. Okay, then ICRC, then the IBRB, this IBRB. Here I not, there is not resistance. Okay, resistor is there. Okay, so IBRB plus VBE, VB base and emitter, this is fixed. Okay, so VBE. Okay, so from this expression we calculate RB. Okay, now alternatively we know VCE, this collector emitter voltage, okay, is equal to the VBE plus VCB. Okay, that means we know that this voltage is the sum of this voltage and this voltage. Okay, so in place of and from this expression we calculate the VCB. Okay, VCB, and in that expression we place the VCC minus uh, VCB. Okay, that means VCB. Okay, and VBE, this VCC and VBE in the place of VCB. Okay, by IB. Okay, now you know this you know this VCC. Okay, this VCC minus VBE. Okay, this minus VBE minus beta IB RC. Okay, then IB. Okay, is converted to RB equal to VCB by IB, and in the VCB place we placed VCE minus VBE, where IB equal to IC by beta. Okay, now sorry now the stability factor in this circuit is less than beta plus 1. Okay, So advantage is that it is simple method, okay. It only required only one resistor, okay. The circuit provide same stability of the operating point as discussed below, okay. Now the disadvantage is that the circuit does not provide good stabilization, okay, and the circuit provide negative feedback which reduce the gain of the amplifier, okay. So this is the advantage and disadvantage. And now the last method, okay, which is normally used uh, very oftenly, okay. So this method, okay, is called voltage divider bias method, okay. In this voltage divider bias method, you see there are two resistors connected between the input or base and VCC. The first resistor is connected between uh, the base and the positive VCC, and the second resistor is connected to the base and the ground, okay, or negative end of the VCC. And also there is a RE emitter resistance here also, okay. So in this circuit, okay, the voltage divider means this VCC is divided in the two resistance, or voltage divided between the two resistance, and the voltage the voltage here, okay, the base in the base is the after voltage divider by the R1 and R2. So this is called, since this is called voltage divider, okay. The circuit analysis, now let us discuss the circuit analysis. Collector current, okay. First one is collector current, okay. The collector current I1 equal to VCC by R1 plus R2, okay. This I1, okay, this I1 equal to VCC by R1 plus R2. Total resistance is R1 plus R2 and the voltage is VCC. So current I1 equal to VCC by R1 plus R2. Then voltage across resistance R2, okay, is V2, okay, which is VCC by R1 plus R2 into R2, okay. This is the voltage divider rule, okay. In the voltage in the R2 equal to VCC R1 plus R2, that is I1, okay, and R2, okay. Now applying Kirchhoff's voltage law, KVL, in the base circuit, that is this, okay. So V2 plus VB plus V2, this V2 equal to VBE that means applying this closed loop, okay, KVL, uh, this that V2 equal to VE plus VB plus VBE. That means VE in the across the emitter resistance and the VB. Okay. Now V2, this VE equal to IE plus RE. Then from that we can calculate IE. Okay. Since IE nearly equal to IC. Okay. So IC equal to this. Also this was this much. Okay. It is clear the expression 1 does not. Then now find the expression of collector emitter voltage VCE. Okay. Applying the KVL of the KVL in the circuit, okay, we get VCC equal to ICRC plus VCE plus IERE, okay. That means VCC equal to IE ICRC, okay, then IERE, then VCE, okay. This is voltage, okay. In this closed loop you can apply KVL, okay. Now from this expression we calculate VCE, VCC minus ICRC plus RE, okay. Then stability factor here, the stability factor is, or stabilization is, in this circuit excellent stabilization is provided by RE, okay. Due to RE the excellent stabilization provided, okay. And consider the equation 1 reveals that V2 equal to VB plus ICRC. Suppose the collector current IC increase due to the rise in temperature, okay. This will cause the voltage drop across the emitter resistance RE is to increase. Also, the voltage drop across R2 is independent of the IC. Therefore, VBE decreases. This tone cause IC to be decreases. The reduced value of IB tend to reduce IC to the original value. So the stability factor here is stability factor by calculating this using formula beta plus 1 plus 1 by beta plus 1 equal to 1. That means stability factor is 1. That is great, very good stability factor for an amplifier. So this connection, voltage divider connection, is generally used for amplification in like 90, 80, 90 cases. Okay, so this is the good good biasing method. Okay, that's all. Thank you.